The next talk is going to be Ákos and Rama from GSK.
Good afternoon.
Hello.
When Ákos asked me to come here and talk about our chemical registration system that GSK and ChemAxon built together, I was thinking what perspective to present. I finally decided that I would just give a glimpse of the entire spectrum of experiences that we had gone through in working with ChemAxon and building the system that we felt is a very challenging thing to take on and also try to finish it within a one-year time frame. So why is it that we are trying to change our registration system? Like everyone else, we're also trying to save some money. So GSK is looking to simplify the IT landscape and reduce IT spend. I'm sure that most of the presentations here where they are looking at changes are also thinking along the same lines where they want to change the IT landscape as well as maybe save some revenue. So one of the programs that was targeted was the registration system, and initial plans were to develop a system where the system itself is hosted outside the firewall, GSK firewall, and is completely controlled and managed, supported by a vendor. And our GSK legal did not agree with that. They were not very happy about that. So eventual decision was made to move to a different vendor in 2011. That turned out to be ChemAxon. And I'm very fortunate that it was ChemAxon that was chosen, and I'll tell you why that is the case. So we chose ChemAxon. We also have decided that the GSK would own the servers, and they will reside within GSK firewall. We would support the servers. ChemAxon would support the service. So that model was, our GSK legal was very happy with that model, so we went with that. So the solution proposed is to host the registration system within the GSK firewalls, and it's a SaaS product, not a RAS product, not registration outside firewalls, but only the service outside firewalls without the IP risk. Moving to the next slide. This is basically breaking new ground because we know that ChemAxon had very limited or no experience in building large registration systems. At least we did not know that they have built before. But we were very confident that ChemAxon is actually up to the task. What we were more concerned with was in the attempt of trying to save money, we are also moving away from Oracle to MySQL. And that, looking at anything, it looks like it's a very risky proposition initially. Optimization routines and you name it. I am sure IT people here can name far more than what I can, but it was a basic concern for us. We were not sure how structures would fare, large objects would fare in MySQL, how would the performance be. Also, JChem, you all know that it's a great platform. However, we're not sure. We haven't used it for registration system before. So that's also unproven. And how would multi-million, almost every large pharmaceutical company has multi-million structures, large and small. And we have to migrate that from what we had before, which is Daylight platform, into JChem platform. So that's another unknown. We're not sure how the migration would work, how the format changes would work, and how the performance would work. We are also doing one more thing. We are moving away from registration using SDFiles. All the data transfer between different systems was through SDFiles, and we just completely want to get away from handling files. We also had a large archives which were holding up shared area spaces full of SD files. So we want to get away from SD files and use a new model where I would describe later called staging, and Ákos is going to demo that too. So completely get away from files, use staging area to do registration. So that's another risk, a complete change from how we were doing things before. One more thing is that we are moving away from V2000 format to V3000 format in order to capture all the stereochemical nuances in enhanced stereochemistry. In order to use enhanced stereochemistry, you have to use V3000 format. However, our upstream systems and downstream systems still continue to use V2000 mol files. We really cannot take on changing all those systems within the 11-month, one-year time frame. So we have to build the system and drop it in such that it fits perfectly with upstream and downstream systems and plays well with it. There is one more challenge here, which is V3000 mol files will deal with enhanced stereochemistry, native enhanced stereochemistry flags. But V2000 does not. So how do you actually translate that information into V2000 mol files? So we had to go with a compromise there. But the two formats have to exist in our system for a while until we move everything to V3000. So again, we have decided that we are not going to change any of our business rules at all. Though we are going to simplify to some extent by, for example, removing the SDFiles and all that, our business rules are not going to change. Very similarly, our data structure is not going to change. Basically, in 11 months, you really don't want to change too much. You want to just replace the system with another system possible and hope that it works as well as the previous one worked before. So parent version preparation is our data model, where parent is, for example, pyridine, and version would be pyridine hydrochloride, and preparation would be several different batches of pyridine hydrochloride. So those are the 3 data levels that we have. We continue to use that model. And this preferred, non-preferred, I'm not sure how many different registration systems have preferred, non-preferred model of compound numbering. When you merge with the different companies, you will end up invariably with more than one compound number for the same structure. So how do you deal with that? What we have done is that we merged them, coalesced them into one compound number and used one synonym as the preferred synonym and the second one as the non-preferred synonym, and tagged all biological data with the preferred synonym, but the non-preferred synonym would be available. However, when you, in the previous system, we had maintained both preferred and non-preferred as 2 different trees. In the new system, we have to merge them together into a single tree. So that's another challenge. That also offers another, a further challenge, which is that when you want to do data comparison to make sure that the migration is working correctly, numbers will not help you anymore, because the number of trees in the old system and new system would be different. Number of lots would be different. Number of synonyms would be different. I'm sorry, number of lots would be the same, but number of synonyms would be different. So that we cannot rely on anymore. So another issue that we have is the way we represented stereochemistry in the previous system was highly proprietary, very rich functionality, but the labels that we have used in order to represent stereochemistry, geometry, and all that are very proprietary markups. So conversion to standard formats was very difficult. Though the proprietary interface that we were given by the vendor was very good, it is able to put together all the pieces and display it very well for us as IT people or registrars in our group. Downstream systems are not able to interpret this cryptic format and display in the same wonderful format that we would look at the data in, especially peptides. They have a wonderful functionality that converts all the cryptic formats into a beautiful display of snake-like peptides that are displayed with all sorts of superatoms and everything. However, when the export to downstream systems was done, they could not see the detail, nor could they see the atom-level structure downstream. So that has been a problem also for us. We are hoping that we would be able to deal with that when we move to ChemAxon. Another issue is novelty checking. We're not sure how enhanced stereochemistry would work when you are comparing diastereomers, exact isomers, enantiomers, and all that. So novelty checking actually is crucial to any registration system, and we want to make sure that it does work correctly. Automation. When I say automation here, we have 2 different types of registration models in GSK. One is bulk registration, another is single registration. Single registration is something where the chemists are looking at each individual structure very carefully and submitting it through either WebReg or eLab notebook. So these are far more important than the bulk compounds that we might purchase from somebody and register them via bulk loader. So a lot of time is spent actually registering. Per compound time is spent in registering the single compounds. So if we automate more automation that we apply to the single compounds, the more time would be saving and resources would be saving. In the legacy system, we have 50% of automation based on achiral compounds and single chiral centers that are known to have been resolved, and the stereochemistry is known. So those 2 classes of compounds are automatically registered, and they form 50% of the total singleton compounds that are submitted from ELN, as you are referring to, and there is another system we have called WebReg. So we also have to maintain the registration throughput in the new system, as well as continue to maintain the SLAs, service level agreements we have with users. And another big challenge that we have is migrating actually 5 million or more records from the old system to new system and maintain the structural integrity in the new system, which is the ChemAxon JChem. So how do we confirm the structure, that the structural migration has occurred without losing structural integrity? That's another challenge. We have thought of many different ways. One of them is that maybe use the same nomenclature program on both structures and generate a name, and then compare the names because they're just strings. Another idea we had was just generate smiles. We have smiles in the previous system, and generate smiles from the new system and compare the smiles, canonicalized smiles. That's one thing. We have used different types of methods, but none of them were completely satisfactory. We were not able to come out with a perfect method where we can programmatically compare all the 5+ million structures easily. Someone suggested from ChemAxon yesterday that INCHI may be a good way of doing that. Maybe we'll actually do that, convert that into INCHI also and run some tests. We still have some more testing to go and some corrections to go, so maybe we can use INCHI now. I have highlighted here a V2000 to V3000 mole file conversion. I have mentioned in the few minutes ago that enhanced stereochemistry is captured in V3000 format, and when we converted that into attached data in V2000 format, it does cause some problems. You cannot actually use chemical nomenclature programs to convert those names correctly. You can name the skeleton, but you cannot actually take into account the attached data that we are using in the V2000 mole files in the chemical names. So that is one of the issues we will be facing and we have faced. Peptide handling. I have mentioned that our peptides were in the legacy system stored in a very cryptic GCT format, and it was very difficult actually. We knew that it was going to be a challenge. It turned out to be a greater challenge than we expected migration. Several iterations it has taken for us to migrate peptides correctly. Until peptides have actually migrated correctly into the new database, we were taking a very manual approach of doing novelty checking, which is basically taking the molecular formula and searching through MySQL databases to see that the molecular formula doesn't exist. If it does exist, you take all the matches and then visually see that it's not an exact match. So that was getting to be really difficult to do. So we knew peptides were going to be very difficult, and it turned out to be difficult. Eventually, we were able to handle it. I will tell you how. Tautomer resolution is another thing. ChemAxon has several different ways of actually representing tautomers, recognizing tautomers. So we had to make a decision of when we migrate compounds from the old database to the new database, are we going to turn on tautomer recognition or not? If we turn tautomer recognition on, compounds that are given, structures that are given different compound numbers might be merged together because they might be perceived as tautomers. If we don't turn it on, we might lose the opportunity where there are some records that may be in fact really tautomers and should be merged together, and this is the opportunity when you can actually catch them and then merge them together. You might miss the opportunity. We actually had to err on the side of caution and say turn off tautomer recognition and migrate compound numbers just as they were in the legacy database. So we went with that. And moving non-preferred data, as I mentioned in the past, into the preferred data tree, that also proved to be a challenge. But we were able to finally, there are still some issues, but we were able to finally merge them together properly. Non-structural data is what we call CST, chemically significant text. When you are not able to represent the structure in actually capture the chemical entity in the form of a structure, you need to describe it in some way such that it is uniquely captured and novelty checking is done correctly. So we use something called chemically significant text, slightly, not very well defined, but there is some control and some standard in generating the chemically significant text, and we use this chemically significant text to do the novelty checking. But for that, you have to capture other fields to make sure that the novelty checking is working correctly. So this is our legacy system, just the data flow of the legacy system. What I would like you to note here is that the bulk reg box here is directly going through server validations. We have ELN and WebReg on the left, and those are the singleton clients. We have Cheshire module sitting in the middle where the SDFiles are processed by Cheshire structure validations in the middle. And then there are some server-side validations that validate the structures that come in before they go into the legacy registry system. If there are problems, they will go to a Windows share. SDFiles go to a Windows share, and registrars would pick up from the legacy registry client the files that are on the Windows share, and then register them. They still go through the server-side validations, and if there are problems, the cycle continues. If there are no problems, the compound gets registered. So we are moving from another point to note here is that the bulk reg is actually a command line, Unix command line interface, and only structures were first registered. After that, SQL loading of lots was done. It's a very risky business, actually. I was always concerned about the process we were using SQL load to directly load lots into an Oracle table. So we wanted to move away from that. And so if you see here, On the left, the bulk reg box has moved from downstream to upstream now. So it makes use of the same web service that ELNB and WebReg make use of. And all of them actually go through the same validation routines. What we have done here is that we have absorbed all the Cheshire validations into standardizer structure checker validations. And that does an additional thing for us. Cheshire validations are based on Cheshire scripts. It requires some specialist to be able to write these Cheshire scripts. We don't have to do that anymore because standardizer and structure checker have GUI, graphic user interfaces through which even a normal chemist who may not have scripting knowledge can also create filters and put them in place. So that makes it easier for us. The other thing is that bulk reg being upstream, all the lots are loaded even before the compounds, which is structures, are sent to validations. So that's the second change. And if you also notice here, there are no SDFiles anywhere except in the initial stages of registration. Of course, if you purchase compounds, thousands of compounds, they generally send the data in the form of SDFiles. So you cannot completely get away from using SDFiles, but you need to handle them. But in the middle of the process, we don't have any SDFiles anywhere. So we got rid of all the shared areas and all that, the bloating shared areas that actually occasionally affect the performance of registration also. And what have we done is replace that with staging area, which Ákos is going to demo later on. So how did we approach the project itself? Initially, we had just written down 400 lines of individual lines of one-liner user requirements, 400 of them approximately. And then we started developing each one of them into a full-blown use case, a pre-condition, post-condition, and then the complete description of the use case. And the use cases that were worked on were, we started on, ChemAxon had started on the simple use cases first, register benzene, and then register something that has a single stereocenter, and register something that has a match on that stereocenter, maybe a diastereometric mixture. So we built complexity on layers upon layers after making sure that the simpler structures are registered correctly. Same thing with migration. We started out with simpler migrations first and then more complex ones. We did not go GSK 1 first and then 2. We did not go chronologically. We went simple ones first and the complex ones later. That has caused some problems because we are not going in the order in which they were initially registered. It has caused some problems, but it also worked out very well for us. So registration rules implementations, as I mentioned here, use cases have actually formed a crucial way of actually starting the discussion with ChemAxon during our meetings and understanding and transferring the business rule explanation to ChemAxon. And we tested all the migrations and registrations with simple cases first. And it's an iterative process. The building complexity from simplicity is an iterative process. However, the initial parts of the project were a cause of concern for us because the delivery was slow. There was not much feedback from either side. And so we introduced something, biweekly sprint plannings were introduced. And after a while, it took time to stabilize, but it was stabilized. And it helped us understand actually how to communicate a use case. Even though you have written the use case and thrown over the wall, it may still not communicate what exactly that is that we want. So we actually we started having meetings almost every day, meetings in the daily scrums, and then hot fix meetings. And right after that, hourly meetings to discuss any knotty problems, very difficult problems that are part of the hotfix meeting. We would discuss with Ákos and one more person that's a technical person. We completely focus on those difficult problems each day. So those regular meetings actually stabilized things, and we started making good progress on receiving good quality deliveries from ChemAxon. So the technology we used in order to communicate with each other were live meetings, Skype, and so on. That helped us meet the aggressive timelines. So this release was scheduled for mid-March, March of 2012. So March 9th, in February, actually, we stopped. We started the final data migration after several iterations of initial migrations and testing. And March was the initial schedule of the final registration release. So registration was shut down on March 9th. And from 10th, 11th, and 12th, after the migration was full, we sat down and compared the data both manually and automatically the structures between legacy registration system and the new system, and all systems were switched off. But submission continued from WebReg and as well as the ELNB. So the submissions were collecting in staging area. After that, on March 15th, we decided that we'll do the first registration. So some submissions were allowed to trickle through. They went into staging. And we were actually hoping that we would give the honor of registering the first one to a registrar, but it turns out that it is an automatic registration. And the second one, second registration was actually a huge hybrid peptide that has both a huge structure as well as CST associated with it. It has caused us some problems because entering the CST into the CST box was not working properly, so we thought we might have to roll back that new version. We did not have to finally. It turns out that resizing the window would let the CST appear. It worked out OK, so we did not have to roll back at that point. At that point, we trickled through more submissions, and we were registered. The next day, all registrars actually sat down together through live meeting, communicating with each other, and they started registering. We did not encounter too many problems, but we took notes, compared notes, and then let ChemAxon know any issues we faced that day. They were immediately fixed, and we were ready for the next Monday to open up registration for everybody. So functionalities were released and deliveries were planned. So after March 19th, when the first release was done, we have ChemAxon had continued to deliver every couple of weeks a new iteration with more enhancements and bug fixes. And what is more important to note here is the fact that ChemAxon actually sat with us on Sundays, waiting for us to test and then make sure that everything is OK, so that during weekdays, there is no disruption for service. So that, I think, GSK had appreciated quite a bit. Very few vendors you would find that are willing to sit on Sundays and work with you and deliver new versions. Over a period of time, peptide handling had improved. We did not have to do molecular formula searches anymore. And another thing we wanted to do was bulk registration of no structures. And ChemAxon helped improve the performance of bulk registration of no structures by 10 times. So this is after they have already released the initial software. So monitoring registration process, SLAs, SQL queries, they were all working fine. And further releases introduced client enhancements. And the bulk registration tool, which was actually inbuilt, the bulk registration tool would allow us to import an SD file and then submit it based on a set of switches that selected to that tell the system how to register, for example, a stereo center, how to register a double bond, so that no registrar needs to actually interfere with it and register each compound separately. You can load thousands of compounds. Ákos is going to demo that too. And we were able to maintain the grid SLAs with the users. So what have we done in the 11 months? New registration system was released. Approximately 6 million records were migrated. Novelty checking was working correctly. Registration is continuing with very few interruptions, though we do have some interruptions occasionally. In fact, they are more non-ChemAxon related interruptions than they are with ChemAxon related. Even if there are interruptions that are with the new registration system, ChemAxon is always on board to fix it quickly or provide an enhancement quickly. And like Ramesh was saying, and someone else, I think Matthew had said, that listening is a skill that a vendor should have, and that I find to be the case with ChemAxon always. Yeah, I am sure that others that have worked with them have also found that. So what else we have done is moved away from SDFiles, shared areas. We simplified our process, and bulk registration has been released. Its performance is improved. And however, what we did not do is, as I mentioned, initial plan was to have the servers and everything outside. Everything is supported and owned by the vendor. We were not able to accomplish that. We brought it inside, and we have reverted the standard vendor relationship back to standard vendor relationship from this RAS service type of relationship. System is not completely being supported by ChemAxon. We have GSK support handling some of the support issues. And installing updates and everything. Though ChemAxon will create the update, they would hand it over, and we would install the update from now on. So the main reason for my being here is the following. It hasn't come without non-trivial difficulties for me. These 2 days have been very difficult and for me to come here and spend time here. One of the reasons, probably the main reason I'm here is because of the relationship ChemAxon and GSK have developed over a period of time through working through this. I felt that it was extraordinary. I have not seen another team that works as well with their partners as ChemAxon did, I think. So this, hats off to them. They have not paid me to say this, but if there's another project in future, I would definitely love to work with them. I'm very fortunate that they chose ChemAxon by the time I came onto the project. So I'm thankful for that, and that's the reason why I'm here. So we worked as a single team. No one has blamed anybody. There were a lot of things that could have gone very wrong. And at the time also, I have not seen anyone stressing out or blaming each other, which I think is an important factor in getting this successfully released. Another important factor is there are actually, the tool that we chose to enter all these bugs and use cases and everything is Jira. There are 1,300 use cases, bugs, and other issues entered in there. And almost half of them are entered by ChemAxon, in even bugs. And if a vendor finds a bug, usually they call it an enhancement or hide it somewhere. ChemAxon did not do that. And this is a testament to their integrity. I admire that. They were equally, Sachi, who was either finding bugs or entering bugs or notifying them that there's a bug found, when I meet her in the morning, so she would say, she would sound equally concerned. In fact, sometimes I had to comfort her that it should be okay. Don't worry about it. So these things actually made me think that it's a very good team to work with. And as I mentioned before, releases, most of the releases were on Sundays. How many people are willing to sit there, even through the night? They're 6 hours ahead of us, still work with us. So that I appreciated quite a bit. Finally, I want to thank these people that I worked with in GSK. Charlie Wilkins is our business consultant. Matt Jones, our project manager. Shane Weaver is our tech lead. Matt Biggs, a developer. Ant Stevenson, a DBA that we worked with. Susan Taylor, a complementary worker that we brought in to do registration while others are handling some of the project work. Very talented person. Ian Mauer, he has done some background work and strategy and all that. Chris Eubank was handling the support issues. Paul Wallace had written some bulk loader, initial code in bulk loader. One person that I forgot to add here is Hazel Barrow, my colleague, and she had done some work. She was not on the project, but did some work. On ChemAxon side, of course, Ákos, hat is off to him. He's a great man to work with. Sarolta doing the testing. Saba. These are all also, in addition to being very nice people, I found that they're very bright people, which is also, it also makes it easier to work with. So many others here, and one name I'm missing here I mentioned is John Lee had initially worked with us, and before the project ended, he moved on. So I want to thank all those people, and finally, I want to thank for your attention. I know it's lunchtime, but thanks for your patience. I'll hand it over to Ákos.
I do have some slides, but these are boring comparing to this presentation. So let's jump to the So basically, this is the interface. I had to change the resolution. I don't know if you can read anything. So I tell. So this is a web-based GUI. And this is the thing that registrars see when first log in. This is the thing called staging area. Now it's empty, the database. Only 4 sorts are added. So this is a place where everything is landing, and then registrars picks up, and then it goes to my staging. I will show. There are other pages, and this one is not present in the working system. This is just for testing purposes to be able to register something. So let's generate some random IDs, and very nice resolution. So first I demo registering a single compound and its tautomer, and then we'll see how much I can get to. So let's register this guy first. It gets the GSK WAM. It's a kind of copy of the GSK system. I could view this on the amendment page, but instead now I open the amendment in a second tab. So I can either navigate between the pages inside this a single page, the interfaces, or I can open in a different tab. So if I just search for this, you can see the structure. Here is the hierarchy, the parent, the version now has the same structure, and the lot is registered under. If there is any salt info, you find on the right side, and there are a lot of things you can do with this structure I will demo later. So let's go back and modify this. I generate some new unique IDs, not to fault staging. And it tells me it's failed. So let's go to the submission page to see what happened. Actually, since it opened the correction page for me, it's already in my staging. So if I go to the staging, you can see this. No, I didn't do anything with it, sorry. So I have to pick it up to fall to my staging. And now it tells me that probably you cannot read. This is the problem, is that this is an existing. So this is a tautomer of something which exists in the database. So what can I do? I can show possible hits. This is a kind of mock registration. Nothing happened yet, just display the matches. If there are several matches, I can select here. But I cannot do anything. This is just an information page. If I click register, then it tells me I'm registering a lot, okay. And now I have decisions, so I can either register as unique or accept this structure or replace. If I say that this is rather the better form, more stable form, but these are the same, then I can say replace. And then if I go to the amendment page, then you see that the GSK one now replaced, and this version has 2 lots. And even at the parent level, the structure replaced. Okay? Let's do something else now. Let's register a mixture. We can currently handle mixtures, formulations, and alternates. These are differently handled. So let's say I register this blockbuster mixture. You have to remember, these are important structures. No. So what I choose is that I set the range. So this is a kind of 1, 2, 3 mixture, and then generate a unique ID. So now I can navigate between the components. So this one is. And if I click register, it is registered under the GSK4. I go to the amendment page and see. So GSK4 is registered as the mixture of GSK2 and GSK3. So the components themselves got an ID. And we can see these. You can see the structure, but there's no version or lot under it. So it is an entity which cannot be directly modified, only through modifying the mixture. Okay, let's go back to the registration page, and let's change the range to 50-50. So, and also I make a mistake here to fall to staging, because there I can show the matches. Otherwise, it would be automatically registered as a new compound. But now let's go to staging. So registration failed, of course. We go to the submission page. It says that this LMB reference is not good according to the regular expressions. So I delete this from the end. And now, if I register, I also have to switch this one because. So what you see here, you have component level matches. So it recognizes that these components are available, or exist. So these exist in the database. I cannot do anything else, just accept, because I have an exact match. There's nothing changed. So if I agree with it, I register. Otherwise I have to change something. I, for example, have to add the chemically significant text, as Rama mentioned, and then I can get a. So this will set the same component numbers for the mixture. But if I continue, I have another level. Now it tells me that I have a match with the components to this mixture. So I can now say that, no, this is something unique. I don't want to register under this, so I can register as a unique. So basically, if we check now the GSK4 is this, and GSK5 is this. Okay. Okay, the time is up. I wanted to show a lot of additional things, but I have just one addition, which we are quite proud of, that isomer versions and isotopic versions or charge versions go as separate versions under the same parent. And then that if you want to modify the structure for whatever reason, you want to change on parent level, then in the past you had to, version fix page jumped up. It was also in the legacy system, I think, the same, Rama. So you had to manually put back the isotopes and the charges because the system could not find out where to put it back. You modify the structure. Now it is automatic. So if you modify something on a parent level, then for example, let's register this. Have the maybe here an isotope. So it went to GSK1. So now you can see it has two versions. This is the A already had, and this is the B. And if I go to parent level and I say I want to modify this structure, then maybe add something here. And it is done. And you can see that. So now it is audited. In the history, it happened. It shows that. And you can see that the structure changed automatically for isotopes and charge versions. So sorry, that was, I have to finish my presentation. There are a lot of other features, like searching or bulk loader. We have a new bulk loader, but I don't have time to show that right now. Thank you very much.
Thank you.